Hi, this is Adolph Oliver, and this is the video clip about solving inequality word problems. Now, hopefully you remember that inequalities have a range of possible answers. In fact, the possibilities are usually unlimited. Anyway, instead of using an equal sign, one of the inequality signs is found, okay? And so you can have the less than, or the less than equals, or the greater than, or the greater than equals. Remember, inequality signs are designed really well. The larger number always goes on the larger side of the inequality, and the smaller on the smaller side, on the pointed side. So once you figure out who's supposed to be larger and smaller, it's real easy to figure out how the inequality sign goes in. And of course, to figure out who's larger and smaller, what you need to do is ask three questions. When you're looking at an expression that you've worked up, you ask, can it be more than the value given? Can it be equal to the value given, or can it be less? If it's equal, then you'll have the equal bars on it. If it can't be equal, then you won't. You'll have strict inequalities like this. Well, let's take a look at some of these to see how this all goes. Okay, here's our first example. You have picked out clothing items that cost $6.45 and $7.88. What can you pay for a third item so that the total is no more than $20? Well, the third item, we have to have some variable for it. Let's just say we use our favorite X. And so here it is. What do we have so far? $6.45 plus $7.88. And then plus the X. This would be the three things we buy, and you can pay so that the total is no more than $20. In other words, that's the maximum you have. Well, okay, that means everything you bought here has to be smaller than the 20. So we point the small side of the inequality toward it. But no more, we can also spend exactly 20 bucks. So the equal bar is appropriate as well. So here's the idea. These are the two things we bought. Here's the third thing we can buy. The sum of all of those has to be less than or equal to $20. That's all that we have. Well, let's do some simplifying here. Combine these two guys together. 5 and 8 is 13. Carry the 1. 8 and 1 is 9. And 4 is 13 again. Carry a 1. 6 and 7 is 13. And that 1 we carried 14. So 1433 plus X has to be less than equal to 20. Okay, well, remember, we solve inequalities just like regular equations. If we ever interchange the sides, we have to flip the inequality. And if we multiply or divide by something negative, we have to flip the inequality. But here we're just moving. This 1433, which is officially plus, has to come over as negative 1433. Okay, we move it to the other side here because we're solving for X. So it's been moved. No reason to flip that inequality. And so let's see, I have 20 minus 14, 60, or 33, I should say. And let's see, I guess the difference here is going to be positive 5 point, and is it going to be 67, I think? So here we go. The third item that we can buy has to be less than or equal to, and of course don't forget to put in your units here, the $5.67, and then we'd be able to pay for it with our $20 bill. Well, a lot of real life world situations are really inequalities more so than equations. That last one was a good example. Here's one that's geometric in idea here, and here's what we're doing with this one. It says the width of a rectangle is fixed at 4 inches. Okay, well, let's make ourselves a sketch of a rectangle here. Here we go. So the width here is 4 inches. It'll be the same down here. What lengths will make it equal to greater than or equal to 30 square inches? Now, by the way, I said the width of a rectangle is fixed at 4 inches. I labeled the length up here. Let's be correct about this. The shortest side is usually taken as the width, so there we go. What lengths will make the area greater than 30 square inches? Well, okay, let's say that x is our length here. And so one of the things we know about rectangles is that the area equals length times width. Well, in our particular case here, we've got the length equal to x, and we've got the width equal to 4. So if we multiply those two together, we get 4x. Okay, that's the area. Area of a rectangle, just length times width. So here we say, okay, that area must be greater than 30 square inches. So here's the area, 4x, and it's got to be greater. Well, okay, that means we put the larger side facing the 4x and the 30 over here. It must be greater than, doesn't say it can be equal, so no equal bar here. So what we have then is the area, 4 times x, has to be greater than 30. Simply divide both sides by 4 here. Okay, and I get x greater than, well, let's see, that's going to be 4 times 7 is 28, and 2/4. Now the 2/4, of course, must be reduced. So what we better end up saying here is x has to be greater than 7 and 1/2. And notice this is inches, so there it is. Okay, well again, we figured out what the area was, 4 times x. It had to be greater than 30, so here it is. We've divided both sides by 4, reduced the fraction. X has to be greater than 7.5 inches. Okay, here's another one. A reservoir. Okay, a reservoir has a depth of 55 feet and is dropping at the rate of 2.5 feet per week. Okay, so, you know, we've got some reservoir here, and this is the water up on top of it here. And the initial depth here, down to the bottom, is 55 feet. Okay, well, since the reservoir's water's drying up, it's going downward at the rate of 2.5 feet per week. Okay, when will the water depth be less than 30 feet? Well, let's say we use W for the number of weeks. Okay, we don't always have to use X. W sounds a little bit better for weeks. So here's what we've got. We've got the initial water depth, but it's being reduced by 2.5 feet every week. So 2.5 times W. Okay, in other words, in 1 week, it'll be 2.5 feet lower. Okay, the depth won't be as great. In 2 weeks, 2 times 2.5 will be 5 feet. It'll be down to 50 feet in depth, and so on. Okay, well, when will the water depth be less than 30 feet. Well, this is the water depth right here. We want it to be less than 30 feet. Okay, so water depth here, less than 30 feet. So the water depth is on the small side of the inequality. Okay, well, let's go ahead and solve this and see what we come up with. This is officially a plus 55. I'm going to jump it over here as negative 55. So we've got minus 2.5W is less than, well, this looks like minus 25. Now, here we go. We got to solve for W. So that means I've got to divide both sides by negative 2.5. But here's something you better remember. Since we are multiplying, in this case dividing, by something that's negative, we have to flip the inequality. So here it is right here. We flipped it. Okay. Well, the 2.5 negatives cancel out, so W has to be greater than. Notice the two minuses give me a plus here, and 2.5 goes into 25 10 times, so the number of weeks has to be greater than 10 weeks. So anytime beyond 10 weeks or beyond, what's going to happen is the water depth then will be less than 30 feet. Okay, let's look at another example here. Okay, here we go. The time for a test cannot exceed 50 minutes, so that means got to be 50 or less. Rosie has already spent 37 minutes on the test. What is the remaining time that can be spent? Okay, well, the remaining time, and this is in minutes, let's say we just use the letter M for the remaining time. Well, here's what we know. We've already spent 37 minutes, and we're going to add onto that the remaining minutes that we can spend. We're going to use the letter M for that. This total here cannot exceed 50 minutes, so it has to be less than 50. But of course, if you don't exceed 50, 50 is also good. So less than equal to 50. Okay, well, once again, we've got the initial inequality set up. Now let's go ahead and jump the plus 37 over to this side. There it goes. Now again, when you add and subtract things, you don't have to flip the inequality. Only if you multiply or divide by something negative. So we don't need to flip it here. M is going to be less than or equal to, well, 50 minus 37 looks to me like that's 13 left. So how much remaining time can be spent on the test? 13, and of course you better label it here, minutes. Okay, one last example to take a look at here. Here we go. This one says Jose got a 71 on his first exam and a 68 on the second. What does he need to get on his third exam to average at least 75? Well, hopefully you remember how averages work out. Let's use our favorite variable here for his third exam. Let's say that's going to be X. So let's add up the scores he's got so far. He got a 71. He got a 68, and what he's going to get on this last test is X. Well, we want the average of that. Remember how you get an average? You add them all up. That's what we started to do here. And then you divide by how many you have. And we've got 3 of them. So adding up these, we know 2 of them. One we don't know yet. But then dividing by 3 will give us this average. Now, the average has to be at least 75, so that means 75 or greater. So this has to be greater than 75, and it can also equal 75. 75 is the least it can be. A higher average we're happy with. Okay, well, here's the thing that can be done with this. You've got this whole numerator up here, and it's being divided by 3. Well, let's turn around and multiply by 3 here. And if I multiply one side of the inequality by 3, I've got to multiply the other by it as well. And these 3's will cancel out. Now, why I did that is it simplifies the problem quickly here and allows me to get down to being able to solve for this x. Let's clean up the left side here. Let's see. 71 plus 68, let's see, 139 it looks like. Okay, so 139 plus x has to be greater than equal. Well, 3 times 75, let's see, 2 times it'd be 150, so 3 times it'd be 225. Well, okay, by multiplying by 3, we got rid of this divide tree, so it made it much easier to continue on here. Positive 139, okay, goes over the other side is negative 139, and of course, when we're moving things, we never have to flip the inequality, so I get x being greater than or equal to, this guy's been moved, let's see, what do we got here? Looks like 61 to make 200, so I would think 86. Okay, let's double check this. And 15, 11, 12 looks good. So the score he has to get on that last exam, the third exam, any score 86 or higher, okay, and he'll average 75 on all of his tests. Okay, well, again, inequality problems like this are very common in everyday situations. So you want to really be familiar with how to handle them.